Here we go. Okay. What we're going to do today is we're going to come up with a nice rule for a derivative so that when you look at the function, you can just know what the derivative is just like that. Okay? Now let's look at some that we already know. For example, this is f of x is equal to a constant. Or suppose you had to say y is equal to 3. Well, that's a graph and it's a horizontal line, right? So if you have a graph that's a horizontal line, what is the slope of that horizontal line all the time? So therefore, the derivative of a constant is 0. So if you ever see a constant, you're taking the derivative of it, it's just 0. I just want to give an example. So suppose we have f of x is equal to x. What does that graph look like? It's a line with a slope of 1. So what's the derivative? Derivative is slope. So the derivative is 1. Doesn't matter where you are on that line. The slope is 1. The derivative is 1. The rate of change is 1. Suppose you have a constant times x. How is that going to change the slope? Exactly. So what would the derivative be then? Yeah, whatever c is. So f prime of x is equal to c, whatever that slope is. Yeah, pencil or... Yeah. So then the question is, what if we have x to the nth? So suppose you had x squared. Is the slope constant for x squared or does it change? It changes. So here is the proof laid out for you. It's really nice and you'll all be able to follow along. It is beautiful. We want to use the limit as h goes to 0 of f of x plus h minus f of x all over h. We want to use that to find the derivative of this function. F of x is equal to x to some power, the nth power. So I will use my formal definition for the derivative. F prime of x is equal to the limit as h goes to 0 of, what do I get if I plug in x plus h? X plus h raised to the nth power minus x to the nth. Shouldn't even have to look at it. If I plug in 0 right now, what would you get? 0 over 0, okay, which we don't know. We have to expand this. In order to expand that, we're going to use our good friend Pascal's triangle. Pascal's triangle is pretty amazing. You can actually find the Fibonacci sequence in it and a lot of other things, the golden ratio, okay? But if I were to add these all up, okay, watch what happens. If you add up the coefficients for this binomial expansion here, here you get 1. What do you get here? And then, yeah, so what would the next one be? Yeah, so it always adds up to powers of 2. That's something that's interesting. Now, here's the other thing that you really have to focus on, okay? This is x plus y raised to the 0 power. This is x plus y raised to the first power. This is x plus y to the second, x plus y to the third, x plus y to the fourth, and x plus y to the fifth. Now, it always starts out with what number? It always starts out with 1. But what happens to be the second number? It's the power, isn't it? Look at that. The second number in the expansion is the power. And that's super important. Now that you've seen that connection, let's lay it out. As I expand this, I have the limit as h goes to 0 of, what will your first term be? X to the nth. Very good. So, okay. So your next coefficient will be, we don't have a 5 up here, will be whatever the power is, right? That's what you're thinking, right? Yeah. And now, oh, hold on, you brought an h up there. As I move along, what's going to happen to the number x's? It's going to reduce by 1, so I'll have x to the n minus 1, and I'll pick up an h. Just, okay, just watch. Okay. Just pause. You can do this, okay? If you have x plus y to the fourth, people, it's x to the fourth, x to the third, x squared, x. And then it's y to the fourth. You pick up a y to the third. You pick up a y squared. You pick up a y. You don't have any there. So that way, all the exponents add up to what every time? 4. And then you put your coefficients in. 1, 4, 6, 4, and the 1. So that's all we're doing here. The difference is this, okay? The n in front simply means that it's the power that we're raising it to, okay? So since this was the fourth power, your second coefficient is 4. Also, look at what's happening to the x. We reduce x by 1 each time. And then it's h to the 1, right? Yeah, very good. So the problem is as we expand this further, we don't really have a good way of figuring out what the coefficient is. I'm just going to write c sub 1 because it's some coefficient. But we do know this. What's going to happen to the x? N minus 2. What's going to happen to h? So h squared. We don't know what the next coefficient is, but we do know it's going to be x to the n minus 3. It's going to be h to the third. What will your very last term be when you expand out x plus h to the nth? It'll be h to the nth. Everybody agreed? H to the nth. And then minus, what do I have? X to the nth. We can't write it all out because we don't know. Yeah, we don't know what n is. If n was 100, we'd have to write 100 of them out. If n was 1,000, we'd have to write 1,000 of them out. So we just have a lot of them, okay? Now, watch what happens, okay? What do you notice? X to the nth goes away. Everything else has an h. So I can divide an h out, right? So I have the limit as h goes to. If I take an h out of this, what's left? N x to the n minus 1. The next piece, what's left? C sub 1 times h. The next one. H squared plus, what's the very last one going to be? Okay. There's something really important for you to understand here. One of these terms is different from the others. There's only one that doesn't have an H. Everything else has at least one H. Would you agree that everything has at least one H except for this first one? So let's let H go to 0. What's going to happen with everything? Rachel, do you remember yesterday you were doing the x to the 5th one? You said that's really annoying. Like I have all these terms and everything canceled except for that first one, right? That's the same exact thing that's happening here right now. We let this go to 0. This is gone. This is gone. Everything here will go away. This is gone. And we have our derivative. Somebody answer the question, why do they all go away? Because h is 0. And so your derivative formula is n times x to the n minus 1. The problem is you're not really seeing what that means yet. I'll show you. It's beautiful. If f of x is equal to x to the 5th, okay? Remember, for x to the nth, our derivative is n times x to the n minus 1. We simply take the exponent and we drop it in front. And then what do we do to the exponent? That's the derivative. Suppose you had x to the 7th, what would f prime of x be? Boom. Suppose you had f of x is equal to, we'll try a tricky one, negative 3x to the 8th. F prime of x will be? Watch this. F of x is equal to 6x to the 4th minus 2x cubed plus 3x squared minus 2x plus 1. The derivative is what? Remember, it's negative 2x would just be negative 2 because that's the slope, and the derivative constant is 0. All you do is you drop the exponent in front. 4 times 6 is 24, and then you decrease by 1. Yeah, so watch this. This is x to the 1, right? So if you move the 1 in front, this is x to the 0. See it? This is called the power rule, and it is awesome. It is beautiful. It makes life wonderful in calculus, and we're going to do it. F of x equals 5. What's the derivative? 0. F of x equals negative 8. 0. F of x equals 4x. 4. F prime of x. Okay, let's go back, okay? This is a constant, okay? This is a constant. What's the slope of a constant? This is a constant. What's the slope of a constant? This is a line with a slope of 4. Now, Kelvin, if you want to think of it this way, this is 4x to the 1. So what we do is we move the 1 in front, so we still have 4, and then we subtract 1 from the exponent. Well, what's anything to the 0 power? 1. So 4 times 1 gives us that 4. Look at this example here. This is 5x to the 0. You move the 0 in front, and then everything becomes 0. Okay? So let's try letter E. Derivative of 5x squared is what? 10x. What's the derivative of 10x? 10. What's the derivative of negative 3? 0. Look at letter D. What's the derivative of negative 3x? What's the derivative of 5? 0. Go get some brain food, come back smarter, and we'll get after it. Twins. Magic number 1. Yep, down to 1 game. Either they win 1 or Los Angeles loses 1. They're automatically in. Nope, 1 game. No, there's 5 games left, and their magic number is 1. Either they need to win 1 of those 5, or Los Angeles Angels needs to lose 1 of those 5. And then we'll be in the wild card playoff with the Yankees at the Yankees. So it's like a 99.9% chance. All right, here we go. Flip it over to K real quick. Okay, we're gonna do K real quick, and then we'll go back. But well, why does it mean anything? And if you shift that graph up or down, does that change the rate of change? No. So we don't care about this number at the end. So this derivative is really simple. But think if we were to do this by hand with x plus h. So what do we get? Sweet. That is awesome. I mean, that's awesome, is it not? So you want to take then the second derivative, and the third, and the fourth, and the fifth, and the sixth, and seventh. Yes, you could do that. Yes, the derivative of the derivative. We'll do multiple and higher level derivatives in not too long. Yep. You just did. Oh, so right. So if I had, say, f of x is equal to 3x squared minus 2, and I wanted to know what's the slope at x equals 1, well, the derivative is 6x, plug in 1, and you get, so the slope at 1 is 6. Yeah, so yeah, you can just look at it now, and it's no big deal. All right, well, let's try some that are just slightly more challenging, okay? So you always know it's going to change a little bit. As we look at f, what makes f a little bit more difficult? Okay, this is where you need to be disciplined, and I'm trying to give you heads up for the mistakes that people make on the test. Okay, it comes down to these type of problems. I am not going to take the derivative yet. So this is my communication that I have not taken the derivative. I'm just writing f of x, and I'm going to rewrite the expression so that it has a coefficient, and it has a variable, and it has a power. 8x to the fifth, 3x to the third, but instead of 1 over x squared, I'll write plus x to the negative 2. 1 over x squared is x to the negative 2 minus x to the 1 half. So as long as you write it where it has a coefficient, variable, exponent, then you can use the power rule. But without that, you can't use the power rule. Okay? So now I'm communicating, I'm going to take the derivative. How do I communicate I'm going to take the derivative? F prime, which is 2x to the negative 3. Very good, Callan. Anybody go to negative 1? You're like, my brain went to negative 1 instead of negative 3. That's a very common problem that happens with people. Okay, thank you, Aaliyah, for being honest. And then minus 1 half x to the negative 1 half. Now, I don't want you to leave the expression with negative exponents, so we'll rewrite it without negative exponents. So we have that 40x to the fourth minus 9x squared. Will the 2 be in the numerator or the denominator? Jake, why is it in the numerator, not the denominator? Because it's 2 to what power? The 1. So this is 2 to the 1 where it's x to the negative third. So this 2 stays in the numerator. The x drops to the denominator. So it's minus 2 over x cubed. And then is the 1 in the numerator or denominator? How about the 2? Denominator. So 1 over 2x to the 1 half, or 2 roots of x, however you like to write it. Now, as soon as you start complaining about that, just think about doing that with f of x plus h minus f of x all over h. Okay? So then all of a sudden it's like, okay, we probably shouldn't complain about it. So I'm going to rewrite this. This is f of x is equal to negative 3x to what power? Negative 5/3. So you can see the mistakes that people make. They write just 5/3, or they write -3/5, or they write 3/5. So the -5/3 is what you must have. Now I can take the derivative. F prime of x is equal to -5/3 times -3. 5. X to the -5/3 minus 1, or -5/3 minus 3/3. -8/3. Okay, -3 times -5 is 15, divided by 3 is 5. Multiplied by -5/3. So I have the exponent, and I'm subtracting 1. So -5/3 minus 1 is -8/3. And -5/3 minus 3/3. We better? Okay, any other questions? You guys are asking great questions. These are the ones that come up. So now I write it. Does the 5 stay in the numerator or denominator? Numerator. Why do you think I'm so emphatic about asking you guys that all the time? Because people mess that up all the time. They drop the 5 to the denominator. Leave it. Okay? The better you do on the tests, the quicker I grade them. I get to go watch my TV shows. I'm in a TV drought right now. I don't have a good show to watch. Ozark? Okay, all right. I want to learn how to launder money. All right. I have not watched House of Cards. It is. Okay. All right. I'll check out House of Cards. Okay, we got 3 left. -2/5 x to the 6/7. -12 over 35 x to the, what's 6/7 minus 1? -1/7. So therefore, f prime of x is -12 is in the numerator, and 35 is in the denominator, along with x to the 1/7. Now, here's a question that people bring up. They're like, well, Mr. Getz, can I write -12 over 35 7th roots, or 7th root of x? I say, yes, those are the same. But suppose you write this. Suppose your final answer is x to the 3/2. And instead of writing x to 3/2, you're going to write that as the square root of x cubed. Technically, this is simplified, and this is not. Because technically, you could take out a perfect square, right? So therefore, I tend to leave mine in rational exponents. And the AP exam will not discriminate which one you leave it as. So I will. So you must simplify it if you use a radical. Okay. All right. This is tricky. What do I do? What do I even do? So I need to use up this negative on the exponent. If I use up the negative on the exponent, that means, I mean, isn't this just f of x is equal to negative, and then the negative will make that, instead of 1/3, it will make it 3. That's what a negative on an exponent does. It flips it. And then it would be x to the -1, right? So I used up the negative. So that's negative what? Use up the square. 9x to the... So in other words, I have f of x is -9x to the -2. So have I taken the derivative yet? No, all I've done is just rewrite it so it's in a power form. Now at this point, I will take the derivative. I indicate I'm doing so by the prime. And I get... Very good. Don't leave the negative exponent, so therefore I have 18 over x cubed. One last example. I think that this one is the trickiest one of all for people. This is the I got you on the test type problem, but this is very important to look at. Now, here's what a lot of people do. I'll just take this middle number, for example, the root of 3. They'll write it like this. They'll write it 3 to the 1/2. And they'll take the derivative, and they'll say it's 1/2 times 3 to the negative 1/2. Why is that just silly? Isn't the square root of 3 just a constant? What's the derivative of a constant? 0. You don't do that unless there's a variable, like an x. See what I'm saying? So do we need to worry about the root of 3 at all? No. All right, so now I've got the root of 5 times x to the 1/2 plus x to the 1/2. So I separate, oh, I'm sorry, yep. And then we'll go minus the root of 3. Sorry about that, thank you. I was just forgetting about because the derivative was 0. Okay, but we should put it there until we take the derivative. You're absolutely right. Please look at the very first part. I took the root of 5x, and I have to rewrite it so that it's got a coefficient. The coefficient is the root of 5. The exponent is 1/2. Does everybody see how I transitioned from here to here? This is 5x all to the 1/2, right? So it's 5 to the 1/2, x to the 1/2. That's how you have to write it if you want to use the power rule. Because we're taking the square root of 5. Remember, the square root of a times b is the same thing as square root of a times square root of b, right? Square root of 35 is the square root of 5 times square root of 7, right? So I'm just separating it like that. That's all I'm doing. Because the 5 is multiplying the variable. There's a variable attached to it. The variable attached to the 3 is x to the 0. And if we were to take that derivative, the 0 would move out front and make it go away. So that's why we have to consider the square root of 5. Okay? Good questions. All right, so here we go. I take the derivative. F prime of x is equal to, I move the 1/2 in front, which will make square root of 5 divided by 2. And it's x to what power? Negative 1/2. Plus 1/2 x to the negative 1/2. And what's the derivative of the negative root of 3? Why is it 0? Because negative root of 3 is a constant. Thank you. So I therefore have f prime of x is equal to the root of 5, and on the bottom I'll have 2 roots of x plus what on the top? 1. What on the bottom? 2 roots of x. Do those have the same denominator? So I have the root of 5 plus 1 over 2 roots of x. Some people have said, well, you have to get rid of the root of x in the denominator. You can't have a square root in the denominator. To be clear, you can't have a square root in the denominator in this situation because we say the denominator has to be rational. Square root of 5 is not a rational number. But 2 over the root of x is not an irrational number. So you can leave it in that situation. Okay? All right. So there's what we got. Good work today. Excellent.